Hello Year 9. First of all, thank you for taking the time to look through this lesson. The PowerPoint that I make and the accompanying video is made so that you continue your learning and make each one specially for you. This week's topic is sequences, and as usual, you should send me the checklist once you've completed the lesson. A copy of this video can also be found here on this link should you need to refer back to it at any time. So first of all, let's have a look at the definitions. You may want to print off the next two slides or copy down the definitions if you're unsure. So first of all, we need to know what a term is. A term is the position of the number in a sequence. So in this sequence, 1, 3, 5, 7, 9, 1 is the first term, 3 is the second term, 5 is the third term, 7 is the fourth term, etc. The term-to-term rule of a sequence describes how to get from one term to the next. So I can see in this pattern that each time I have added 2 to get to the next term. So the term-to-term rule of this sequence is add 2. When you see dots after a number, it means the pattern will continue using the same rule. The nth term of a sequence looks a little bit confusing because it uses a letter. However, this is just a formula in which we can substitute the term value to find the number in the sequence. So for example, if I wanted the second term, the second number in this sequence, I would do 3 times 2 and add 1. So I know the second number in this sequence would be 7. You're often asked to use this to find a number that would take too long to write out. So the 50th term of the sequence, you wouldn't want to write out 50 numbers. Instead, we use the nth term. For the 50th number, I can do 3 times 50 and then add 1. And that would be 151. There are several different types of sequences. The most common one that you will see is a linear sequence, where the difference between the number is always the same. Those numbers could be increasing or decreasing, but it will always be the same. In this example, the difference is -3 because each time we are taking away 3 to get from one term to the next. A geometric sequence does not have a common difference between the numbers by adding or taking away. Instead, we can multiply. So here, each number is double the previous one. 2 times 2 is 4, times 2 is 8, times 2 is 16, and so the numbers will go up fairly quickly. A quadratic sequence is a sequence that uses squared numbers. So this sequence of numbers is called n squared because the term value, the term number, has been squared. If I wanted the 10th number in this sequence, all I'd need to do is 10 squared, which is 100. A Fibonacci sequence is a special type of sequence, and to get to the next term, you add the 2 previous numbers before it. So if we're starting at 0 and the next number is 2, the third number would be 0 plus 2, which is 2. The fourth value would be 2 add 2, which is 4. 4 add 2, which is 6. 6 add 4, which is 10. And the next number in this sequence, 10 add 6, would be 16. I'm now going to show you some examples that are exactly like your Maths Watch homework. So either copy these down or print this page off and refer back to them in case you get stuck with your Maths Watch. Question number 1 says, what's the term-to-term rule of the following numbers? So I can see that the difference between these numbers is not the same. So it must be a geometric sequence where we've multiplied. In this case, each number has been multiplied by 3. So my term-to-term rule is multiply by 3. In the second example, each number is going down by 10 times. So we're dividing by 10. So my term-to-term rule is divide by 10. Number 2, we're told that the term-to-term rule of a sequence is divide by 4. We're told that the fourth term is 10 and we need to find the first term. So I'm going to write down first, second, third and fourth, and underneath the fourth I'm going to write 10 because we were told that the fourth term had a value of 10. Now, if the term-to-term rule is divide by 2, I need to work backwards to know what the third term may have been. So instead of dividing by 2, I'm going to multiply by 2. I then multiply by 2 again and multiply by 2 again. So if I go backwards and just check my answer, 80 divided by 2 is 40, 40 divided by 2 is 20, 20 divided by 2 is 10. So I know my answer of 80 is correct. The first term is 80. Number 3 is just like number 1. We want to know the term-to-term rule of this sequence. I can see that each term has been divided by 4. Now number 4 uses one of those definitions we looked at earlier. We're asked to find the next term of this quadratic sequence. Now if you remember, a quadratic sequence uses square numbers, but the numbers given to me aren't square. I'm going to write down my first 4 square numbers to help me with this. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. I then need to have a look and see how do I get from the top row to the bottom row. Well, in this case I can see that I could add 5. 1 add 5 is 6, 4 add 5 is 9, 9 add 5 is 14, 16 add 5 is 21. So what I need to do to find the next term in the sequence is have a look at the next square number, which is 25, and then add 5 to it, which gives me 30. Now sometimes you get a question that involves patterns. So number 5 says, how many squares will there be in pattern 9? I've been given the first 3 patterns, and so what I'm going to do is count how many squares are in each one. The first one has 3, 5, 7. So I can see that not only are these odd numbers, but the difference between them is add 2. So if I want to have a look at pattern 9, I can count up to 2 each time. So pattern 4 would have 9, pattern 5 would have 11, pattern 6 would have 13, pattern 7 would have 15, pattern 8, 17, and finally pattern 9, 19. Question number 6. The first term of a sequence is 17 and the term-to-term rule is take away 7. Work out the third term. So this is easier than question number 2 because we've been given the first term, which we know is 17, and I just need to take away 7 each time. So 17 take away 7 is 10, take away 7 is 3, so my answer is 3. The next set of examples, you're given the nth term. It may look confusing, but it's actually quite easy. The nth term of the sequence is 4n minus 2, and we want to know the first 3 terms of the sequence. So for the first term of the sequence, I need to do 4 lots of 1, take away 2. 4 times 1 is 4, take away 2 is 2. For the next number in the sequence, the second term, I'm going to do 4 times 2, take away 2. 4 times 2 is 8, take away 2 is 6. And for the third term, 4 times 3, take away 2, and I get the answer of 10. So the first 3 terms are 2, 6, and 10. Here's a similar one. We want the first 3 terms again. We're told that we need to do 20, take away 3 lots of n. So every time I'm going to do 20, take away something. So the first one, I do 20, take away 3 lots of 1, which is 17. For the second term, I do 20 take away 3 lots of 2, which is 14. And for the third term, I do 20 take away 3 lots of 3, which is 11. So the first three terms are 17, 14, and 11. Here's another one. The nth term of the sequence is 3n minus 4. So for the first term, I'm going to do 3 times 1 take away 4. That's going to give me an answer of minus 1. For the second term, I'm going to do 3 times 2 take away 4, which is going to give me an answer of 2. And for the third term, 3 times 3 take away 4 is 5. So the first three terms of my sequence are minus 1, 2, and 5. For question 10, the nth term of the sequence is n squared plus 4. So what I need to do is square my term and then add 4. So for the first term, I need to do 1 squared, add 4, which is 5. For the second term, 2 squared, add 4, which is 8. For the third term, 3 squared, add 4, which is 13. Number 11, the nth term of a sequence is 9 take away n. So for the first term, 9 take away 1. For the second term, 9 take away 2. And for the third term, 9 take away 3. So my three terms are 8, 7, and 6. And finally, a Fibonacci sequence begins 2, 2, 4, 6, 10. We need to find the 7th number in the sequence. So you need to look back at your definitions and know that in a Fibonacci sequence, the next term is found by adding the 2 previous terms. We've been given the first 5. So the 6th number in the sequence would be 6 add 10, which is 16. And then the 7th number would be 16 add 10, which is 26. If I wanted the 9th number, I can continue on, find the 8th by adding 16 and 26, and then the 9th one would be 42 plus 26, which is 68. When you finish the examples, you can try these 7 practice questions. The answers are on the next page, and only when you finish that can you go onto the Maths Watch. If you still need extra practice, then you can click on these links and try some Corbett Maths questions. The questions can be found on this link or this link, and the answers to those questions can be found by pressing this button or through this link. Remember, only attempt the Maths Watch when you have finished all your examples, and remember to email me if you need any help. Thank you.